Hello, everybody, and good afternoon. Thank you for joining us for Docker for Windows Containers and Kubernetes. Our speakers today are Simon Ferkel, a senior developer out of our Paris office for developer solutions, and Carl Fischer, who's a senior product manager with Docker. Go ahead, gentlemen.
Okay, thank you again for coming this afternoon. My name is Carl Fischer. As David mentioned, I'm a product manager at Docker focused on Windows and Docker certified infrastructure.
Yes, and I'm Simon Ferkel, a senior software engineer at Docker in the Paris office, working on various developer-oriented stuff like Docker app, Compost on Kubernetes, and Docker desktop.
So we're going to talk about three things today. The first is where things are currently with Windows support in Docker technologies. The second is Simone's going to give us a nice demo of a mixed cluster that's running Windows and Linux pods side by side, something that we've been working on for a while. And then we'll close with just a quick look at the roadmap in this space going forward. So where are we today? Well, actually, there's a lot of support for Windows today in the Docker ecosystem and in the Docker core products. So, for example, the engine for enterprise Windows Server has had over 500,000 downloads. We've got support for mixed Windows Linux clusters in the Docker Enterprise product that supports 2016, 1709, and 1803 versions of Windows Server. And we put a couple logos on the side here of customers who are here speaking about their journey with Windows containers. Get asked a lot about where are Windows containers on the continuum of toy and production. And those companies should be able to give you some good information on that question. On the desktop side, over 450,000 monthly users of the Docker Desktop for Windows product. So it's very broadly used and growing. It's capable of running Kubernetes today, including on Windows. And as was announced this morning at the keynote, Docker Desktop Enterprise is our newest offering that's going to provide capabilities for higher management of deployments and settings. So just a quick look at where we were this year for calendar year 18. So we've been working with each version of Docker Enterprise to add more capabilities around Windows, and that dovetails with working with Microsoft on Windows Server itself and providing improved capabilities there. So it ends up here at the bottom with Docker Enterprise 2.1, our release earlier this quarter, or late last quarter. And that finalized the support that we wanted to add around Server 1709 and Server 1803 and Server 2019. So all that is now in the product. So where are we with regards to Kubernetes and Windows? So we get this question a lot. So the first thing that a lot of people don't understand is that there is not currently support in Kubernetes for, there isn't currently GA support for Windows workers in upstream Kubernetes. So that's something that's been under active development, continues to be under development, and is currently targeted for March or Q1, Q2 timeframe next year. So when that lands, there's a couple of things that are important to understand. The first is that it will run on Server 2019 only, and so that's going to cause some limitations for certain customers in terms of how quickly they can get onto a Server 2019 infrastructure. The second challenge we wanted to call out is around using Active Directory authentication from within containers. And there's a Windows platform capability for that called Group Managed Service Accounts, or GMSAs. And so if you have an application that requires that, which almost all legacy applications will, require some kind of NTLM authentication off of the box or outside the container, then those applications won't be able to be used under the initial Kubernetes release either. But the good news is there are options in the meantime. So Docker Enterprise today has support for Server 2016 all the way up through 2019. And it also has support for the GMSA container authentication. So the net here is that you can start your legacy migration now and not have to wait for Kubernetes to become GA in order to get started. And the last piece that's a key to make that happen is there's a capability built into our Kubernetes offerings that allows seamless migration of workloads from Swarm into Kubernetes. So you can get started now, run Swarm, and when things are ready with Kube, you can migrate easily. All right, let me hand it over to Simone, and he's going to show us a demo of Docker Desktop.
Yeah, so like Carl just said, it's not ready yet. We are on a journey to Kubernetes and Windows, and we do not that alone. We have to do that. We have a lot of partners, being Microsoft, obviously, but also partners who write CNI plugins and other infrastructure features for Kubernetes clusters. So it's a work in progress, and where we are now is for the Docker for Desktop side. We had a prototype that we showed earlier this year at Microsoft Ignite, which introduced basic support for Windows workloads on Kubernetes. And today I'm going to show you an updated version of this prototype, which also brings Compost on Kubernetes support. And we are targeting a general availability for sometime next year, hopefully, on the Edge channel. And for the Docker Enterprise side of things, we are on an early prototype, and due to the production nature of Docker Enterprise, we might introduce a bit more of delay, but we are not fixed on a roadmap yet. So let's now focus on developing on a mixed cluster and developing mixed workloads and what it means for the developer, and how we envision that. So just for a quick presentation, how Docker Desktop will work with a mixed cluster. First, it leverages the existing Docker Desktop architecture. So we keep our Linux Kit-based VM, which is still running the master node. And what we did is just make sure that the Windows host itself registers into this cluster as a worker node. On the networking side of things, we did something that was really relevant for us. It's the ability to configure services and pod CIDRs for your cluster. And that's necessary because now pods don't only have to talk to each other on the same host, but have to cross the boundaries to reach pods running on Windows. And so we need to make sure that we have no conflict with your networking environment. So that was a requirement. The second thing that we did in terms of networking is that we wrote a custom CNI driver for Docker Desktop that worked in concert with HNS and had a bit of custom configuration and hacks, in fact. And this way, we can support workloads running both on a Windows server and on Windows 10 client. Sorry, with Hyper-V container support. The way the networking works on Linux is that we have a simple CNI bridge which allows something quite native for developers. It's from the host. I'm capable of reaching every pod, being Windows or Linux pods, without to rely on services, on Kubernetes services. So it's really handy for developer because this way you can attach a debugger to any running pod without having to declare a service that proxify your remote debug agent or anything. So now about the code. Building an application for a mixed cluster is really close to dealing with an homogeneous cluster. One of the most important things to know is that you need to give some hints to the scheduler so that it knows that a particular workload, a particular pod, must run on Linux or on Windows. So to do that on Kubernetes, we have an object that is called node affinity, a node affinity. And this allows you to do things like that. So as an example, this little YAML snippet makes sure that the pod that you are declaring runs on Windows only on a machine running on a MAD64 processor architecture. We have just begun the work on persistent volume claims and persistent volume drivers with Windows nodes. And what we envision also is that the options that you will pass to the persistent volume claim provider might be a bit different for Windows and Linux workloads, mainly because Windows and Linux do have quite a different file system. And so that's something we didn't have time yet to tackle properly, but we envision some challenges in that subject. With Compost and Kubernetes, we already support mixed workloads with Swarm, and we have a constraint based on deployment constraints. And what we did for Compost on Kubernetes is that we try to make this as seamless as possible. So we pass these deployment placement constraints, and we transform that actually into node affinities. So any mixed workloads that work today on a mixed Swarm cluster will be able to run as is on Kubernetes. So, time for demo. So I am on my machine on Windows 10 client, and I have installed this prototype of Docker for desktop. And the first thing I will show you is just if I do a kubectl get nodes, we'll see that my cluster has two nodes. One which is Docker for desktop. We didn't change the name. It's actually the Linux Kit VM running the control plane. And there is this Simon XPS. Simon XPS is the name of my machine. And so my machine by itself is a worker node in this cluster. So obviously there are two flavors of the Docker engine running there. There is one running in the VM, one running on the desktop. And they are all, both of them are running at the same time. And so we have to bring an experience as well to make sure that you can switch from one to the other quite easily. So let me introduce Docker context. So Docker context, it's something that is quite similar to the context in the Kubernetes world. So that's basically a store of credentials and endpoint configuration that will ship in the Docker CLI in the near future. And that allows you to quickly switch from one cluster to the other, so or from one Docker endpoint to the other. So as you can see here, my current active context is the Linux one, And so if I do a Docker version, we see that the server is running on Linux. And if I do something like using this context global flag and target my Windows endpoint, I can now use all these subcommands from the Docker CLI through there. So this is my Windows node, and I can also do that for context related to slightly more complex remote hosts, like a Docker Enterprise deployment that I will use later. There are many things that you can do with context. You can use environment variable to pin a given context. You can quickly change what is your default working context, things like that, but that's not the subject. So if we go back to Kubernetes, I also want to show you that by doing a kubectl get nodes, my machine name. Oops, kubectl get nodes. That's better. You can see that it's really registered as a Windows 10 Pro. It's not a Windows server, so it will run on any developer machine. So I also talked about the importance of node affinity. And node affinity is not only required for your workloads, but it's also required by us for making sure the control plane is really restrained to running on Linux. And so, for example, if I grab this piece that will show me, it will show how the kube proxy daemon set is configured. You'll see that we have a node selector expression there that makes it constrained to Linux nodes. So we change that in the way we set up the control plane. So to show you a bit more of application code, I will use a Docker app thing. So if you saw the demo today, you should expect some Docker Compose files and things like that. So here's my Compose file. It's basically a very simple application with two services and two web UIs. And actually, it's a Windows. There is one Windows service, one Linux service, and one Windows UI and one Linux UI. Each of them has placement constraints described in a Swarm style. And we'll see that it will just work with Kubernetes as well. So what are the images that I use for my service and UIs? They are really a simple piece of code. So first, the service. It's just a simple web API that just returns some info about the OS that is running the current container and the machine name. From the UI side, what we do is just call this API, and sorry about that. We call this API. I have just a DNS lookup there, just so that we can pass a service name to reach. And we call this API, and we just render that as part of the page. So let's see how it works. Oops. I will just do a Docker app install. Timo mix. Yes, with. Yeah, sorry about that. So the Docker app thing is deploying my stack on my Kubernetes cluster. Service is going to come alive. Yeah, everything is alive. So what it did is just create a new stack. So let me look a bit of what it means. So kubectl get stacks. Stacks are actually a Kubernetes object that we added with the Compost and Kubernetes controller. And so we'll see that we have a bunch of services with my different images. And we see that we passed correctly the placement constraints and detected that it was actually operating system constraints. And so we are capable of generating node affinities for all these components. So next thing that does Compose and Kubernetes controller is that it gets the stacks and create native Kubernetes objects from that. So let me see what kubectl get all gives us. It gives us a list of deployments and replica sets, plus some services to expose my different workloads. And we have here all our pods, Linux and Windows. If I describe this one, for example, kubectl describe. Okay, we'll see somewhere. Actually, no, we don't see with that. I just have to change this a bit. So get, yeah. So if we look at the pod template that has been generated for this pod, we'll see that it has a node affinity with the constraint on OS and processor architecture. So now for the tricky part, does it work? Let me print kubectl get all. So I've exposed the Windows UI on localhost port 4242 and the Linux UI on 4243, and we should see. We should see that actually can reach my Linux service from there. So I'm running the UI on Windows, and I try to reach the Linux service, and we see that it's actually a Linux OS that answers, and yeah, I can also target my Windows service as well, and it works. And it works also the other way around. So if I go to my Linux UI, it's running the same application but on Linux, and I'm also capable of reaching my Windows service, which run on Windows on my machine. So that's a quite simple way to work with. And now, what could I do to work with a production cluster and running Swarm? Actually, the Docker app thing is capable of deploying both on Swarm and Kubernetes, so I can get the exact same application and deploy it now on my Docker EE cluster. So I will use Docker app for that, and create a new installation of the same application, and use my remote Swarm context. for that. I will also change the default port, so I have prepared a file with the necessary settings. So I have to change the ports because they are 42, 42, and 42, 43 are not exposed on my remote cluster. The firewall blocks them, so I change that. And if I go now to my Docker E Kubernetes cluster, yes, sorry, I installed it with a self-signed certificate, sorry about that. If I go to my stacks in Docker E, I should see this one coming up. So yeah, demo mixed remote, and we should see Swarm services and things like that. And I just bookmarked the Windows and Linux endpoints. And so the same application is now running on Swarm. And I can use the same DNS names for reaching the other services. And my Windows service is still capable of reaching Linux service and Win service as well. So that's it for the demo. Let's just come back to the slide. And I give you the end.
Very nice.
It's always the networking that makes it hard, every time.
Yeah.
So let's take a look at the roadmap real quickly here. Start of 2019, we'll have support for Server 2019 with Swarm. As we go forward into 2019 and our next Docker Enterprise release, we're going to have the Kube Windows workers with Docker Enterprise that we talked about earlier. Along with that, we're planning to do some work around improved user experience and security for the GMSA support that we mentioned earlier, the Group Managed Service Account support for authenticating to directory services. And then we're working with Microsoft on futures in the Windows platform around GMSA improvements as well. That's something that has become very clear is critical to enterprise deployments. And so both companies want to work together to improve that as much as we can. So just to wrap up, we talked about Docker having wide support for Windows today under Swarm. Docker Enterprise support for Kubernetes Windows is coming, and in the meantime, the Compose on Kubernetes support that Simone demoed allows you to start with Docker Swarm today and seamlessly migrate your investments to Kubernetes when it's available. And then, as we demoed, we've got continued prototyping on this space, specifically around the developer experience. And clearly, there's an important set of scenarios around using Kubernetes with Windows in production. I think what people tend to miss is what we've been talking about today with Simone's demo is the importance of having that on the developer desktop side too, so that you can have a seamless story from start to finish. All right, a little bit of housekeeping. Many of you know that Windows Server 2008 is going to go out of service in January 2020. So we have a pretty extensive program available for helping customers migrate applications that are stuck on Server 2008 or even Server 2003. So check that link out if that's interesting to you. There's a Forrester report that came out recently that is also very interesting. Docker placed in the leaders quadrant, and there's lots of good reasons why that's the case. This isn't just self-promotion. It's good information to have as you evaluate options in this space. So there's that. And then finally, we want to ensure that the sessions that we provide for you are high quality and of high value. So please fill out the survey so we can get your feedback and we can continue to work on things going forward.
Yes, although I forgot to mention, but we are hiring in Europe around the developer solution things. So if you are interested in working on Docker Desktop or Docker App or Compost on Kubernetes, just reach us and send your resume, and it will be a pleasure.
All right, thank you. So we still have about 10 minutes left, so we're going to open up the floor for Q&A. If anyone has any questions, I'll come by and bring the mic to you. Oh, we got one right here. Okay, so.
Yeah.
Am I allowed 2 questions, or is it just 1 question per person? Okay. You mentioned the difficulties with group managed service accounts and Windows authentication. You also said NTLM. I was wondering if an application uses Kerberos to authenticate to Active Directory, would that work, or is it the problem with NTLM, or is it any Active Directory authentication that's the problem?
It's going to be any Active Directory authentication, any type of authentication to Active Directory from inside the container, because by default a Windows container runs as a container admin process that doesn't have any permissions anywhere other than inside the container itself.
So Kerberos delegation wouldn't work neither, I guess.
Right.
Okay. The other question I have is, are these challenges specific to Kubernetes? I mean, if we run Docker Enterprise with Swarm, do we have a problem with Active Directory authentication then on Windows Server? Yes.
Yeah, it's independent
Okay.
of the orchestrator. Yeah,
Okay.
that's right.
So we really need that feature to be generally available to be able to use authentication on Windows containers.
That's right. And it is generally available today with Swarm.
So with Swarm, we can use Active Directory authentication?
Yes.
Okay,
Yeah.
good. Thank you.
Yeah, and there was a session just earlier today. It was called "Don't Have an Identity Crisis," something like that, where they went deep dive into this topic of GMSA, and they covered Kerberos delegated as well. So if you didn't catch that, it's a good one to, when the recordings come out, that's a good one to follow up with.
You have one in the back.
Thank you. Back with Active Directory again. Are there any constraints of the level of domain, even with working with Swarm, or will all domain levels work?
Domain levels in terms of
2008, 2012, 2016
yeah, it
domains?
needs to be, you need to have at least one 2012 domain controller in your forest.
Thank you.
Yeah.
Even if it's a 2008 level domain running on a 2012 domain controller?
Yeah, because once you bring that domain controller in, it'll upgrade the schema to 2012, which is what's needed for the group managed service account support.
Right, okay. I'm not sure about that one, but another date.
Anybody else? Any other questions? Oh, here you go.
Is it the prototype you are showing, is it available to download and try to use right now, or is it internal prototype you just showed us? I mean the Docker desktop you showed today? Is it available for wide download or just internal use?
No,
of
for now it's purely internal. It's kind of work only on my machine today. So no, it's not widely available, and we might introduce previews in the Edge channel before we are completely ready, but it remains to be planned.
Thank you very much.
And we are not sure yet if we are going to support every single version of Windows 10, or if we will support Windows 10 RS5 onward only.
Any other questions from the audience? So Carl, I actually had a question. I didn't see it covered. It was about Windows Server 2008. What does that mean for folks? What are you seeing?
Right. So Server 2008 going out of maintenance or being end-of-lifed in January 2020 means that it's no longer going to get service updates and, most importantly, security patches being backported to it. So if you have apps running on those versions of Windows Server in your environment, you need to think about doing something. And so that's where our program for migrating those applications, which Elton demoed this morning, being able to migrate those, use containers to modernize them, migrate them onto current infrastructure where you're going to be getting security patches is what's important about that Server 2008 going out of end of life.
All right, thank you. So I want to thank everyone for joining us today. And if you have any other questions, you can come and talk to our speakers up at the front. If not, have a great show. Thank you.